How do exoplanets form in our universe? Have you ever looked up at the night sky and wondered how those distant planets came to be? The answer lies in the fascinating process of exoplanet formation. Exoplanets primarily form within protoplanetary disks, which are vast, rotating clouds of gas and dust surrounding young stars. This process begins with tiny dust grains, smaller than a human hair. These grains collide and stick together, forming larger particles. As these particles grow, they transform from dust to pebbles, then to rocks. Eventually, they become kilometer-sized bodies known as planetesimals. This initial stage is critical because these planetesimals serve as the building blocks for planets. There are two main theories that explain how planets grow from these planetesimals. The first is the core accretion model. This model describes a bottom-up process where a solid core forms first by accumulating planetesimals. Once this core reaches a critical mass, around 10 times the mass of Earth, it begins to attract and accumulate gas from the surrounding disk. This forms a thick gaseous envelope around the core. This model accounts for the formation of both rocky planets and gas giants like Jupiter. Typically, this entire process takes a few million years. Recent research suggests that gas giants can form even more quickly than previously thought, within 1 to 2 million years instead of 3 to 5 million years. The second theory is the gravitational instability model. This approach suggests that parts of the protoplanetary disk can become gravitationally unstable and collapse directly into giant planets without forming a solid core first. This process can happen much faster but is thought to be less common. The environment within the disk plays a significant role in this process. Regions farther from the star, where it is cold enough for water to freeze, allow icy particles to stick together more easily. This helps form massive planetary cores that attract gas, leading to the creation of gas giants. In contrast, closer to the star, where it is warmer, rocky planets are more likely to form. Understanding how exoplanets form is important for several reasons. It informs our knowledge of the origins of planetary systems, including our own. This knowledge can inspire educational initiatives and scientific investments. Additionally, insights into planet formation can guide future space exploration policies, including the search for potentially habitable worlds. Supporting research in this field can enhance a nation's leadership in space science and technology, fostering international collaboration and innovation. Recognizing the processes that shape planetary systems highlights the value of protecting Earth's environment, given the rarity and fragility of habitable conditions. In summary, exoplanets form through complex interactions of dust, gas, and gravity within protoplanetary disks, primarily via core accretion or gravitational instability. This knowledge not only advances science but also has practical implications for policy decisions related to space exploration and education.